Welcome to the deep dive. Today we're digging into something pretty fascinating. It's where artificial intelligence meets, well, understanding itself.
Yeah, it's a really interesting space. We've got some, mind-bending things to look at.
Definitely. Like AI that can basically pull images out of your head just by looking at brain scans.
And also how it's changing fields like audiology, hearing, healthcare.
Right. And we'll also get into those bigger questions like, can machines really understand things the way we do, or even, be conscious?
Exactly. So if you're curious about what all this AI buzz actually means, maybe for us, for our future, and you want the key ideas without wading through super technical jargon, this is for you.
Yeah. Our mission today is basically to pull out the core insights from quite a mix of sources, articles on AI and philosophy, the brain scan study, audiology research, AGI debates.
And connect those dots, hopefully, so it all makes a bit more sense. Give you that clearer picture of where AI is now in terms of understanding and, where it might be headed.
Okay, let's start with that sci-fi sounding one. The AI recreating images directly from brain activity. It sounds incredible.
It really is. This study came out of Japan recently.
And how did they actually do it? Because that sounds complex.
Well, what's really innovative is their approach. They used a system called Stable Diffusion. You might know it. It's one of those AIs that makes images from text prompts.
Okay, yeah.
But they trained it differently. They took thousands of photos, paired them with text descriptions of those photos,
Right.
and then linked those to the specific patterns of brain activity recorded when people looked at the photos inside an MRI scanner.
Wow. So it's learning to connect three things: the image, the words describing it, and the brain's reaction to it.
Exactly. And the key thing, the clever part, was using both the text and the visual information. It meant the AI needed less training data from each person compared to older methods that maybe only used visual links.
That makes sense. It's got more context to work with.
Right. Ariel Goldstein over at Princeton called it a new way to decipher the brain, using these two different but complementary information streams.
So it learned to associate brain patterns not just with, say, cat, but maybe cat sitting on a mat viewed from above?
Pretty much, yeah. The content, the layout, even the perspective.
And how did they test if it actually worked?
This is the cool part. They'd show someone a new picture in the scanner, one the AI hadn't been trained on specifically.
Okay.
The AI would start with just visual noise, kind of like TV static. Then, using the live brain scan data, it would gradually shape that noise.
Into an image matching what the person was seeing.
Exactly. By matching the brain activity patterns to the patterns it learned during training.
And it worked.
It did. They showed it could reproduce the general look, the layout, and crucially, it recreated novel images, things like a toy bear, an airplane, a clock, a train.
Things the specific brain scans used for testing hadn't been part of the initial training set.
Correct. Which strongly suggests it wasn't just, memorizing specific photo-brain pattern pairs.
It was generalizing. It learned the underlying code, almost.
That's the idea. Iris Groen at the University of Amsterdam was quoted saying the accuracy was really impressive compared to previous attempts.
The potential applications they mentioned: exploring animal perception, recording dreams, helping paralyzed people communicate. That's huge.
It really is. It feels like a significant step using AI to interpret brain signals in this sophisticated way.
And you mentioned this kind of sophisticated processing is also cropping up in audiology. Hearing healthcare.
Yes, absolutely. The research we looked at shows AI integration there is really taking off.
How so? What does AI do for hearing?
Well, think about traditional hearing tests or fitting hearing aids. It often involves a lot of manual adjustment, subjective feedback. Is this better? How about now?
Right, yeah.
AI offers the potential to make those processes, more precise, more efficient, and much more personalized to the individual's specific hearing needs.
So not just faster, but potentially better results for people.
That's the goal. The studies we reviewed kind of trace the history you had, early rule-based AI, then the boom thanks to faster computers and big data.
Which led to machine learning.
Right, ML algorithms learning from data without being explicitly programmed for every single step. And then deep learning, DL, which uses these complex, layered neural networks.
Like the ones good at recognizing speech or images.
Exactly. Which is obviously very relevant for understanding speech in noisy environments, a key challenge for hearing loss.
Now we also have things like generative AI. and large language models, LLMs.
Yeah, generative AI creating new content, and LLMs like GPT-4 understanding and generating human-like text. All these different types of AI are finding roles in audiology.
Okay, so how are they being applied, like specific examples?
We're seeing AI used to improve the accuracy of hearing assessments themselves, also to help automate the fitting of hearing aids and cochlear implants.
Making the adjustments, maybe.
Yeah, or suggesting optimal settings. And it's also being used to optimize auditory rehabilitation programs, the training people do after getting hearing devices.
Sounds like it could really help audiologists, maybe free them up from some routine tasks.
That's definitely one of the potential benefits highlighted, enhancing their capabilities, letting them focus more on complex patient needs, leading to more personalized care.
And you said the research is growing fast.
Exploding, really. There was some groundwork early on, but very little between, say, 1990 and 2009. Then it picked up a bit in the 2010s with more focus on machine learning.
But the last few years.
That's when it really surged. From 2020 to 2024, that period accounted for almost 90% of the studies reviewed, driven by deep learning and LLMs.
Wow. Any particular countries leading the charge?
The US, Germany, and China were mentioned as the most active based on the number of studies, and key journals publishing this work include Ear and Hearing and the International Journal of Audiology.
Okay, what kind of studies are they doing mostly?
A lot are observational studies looking at how AI is being used, its potential, but a really significant area is developing AI-based prognostic models.
Prognostic. So predicting things.
Exactly. Using AI to sift through patient data, find hidden patterns, and predict things like how someone's hearing might progress or how well they might respond to a treatment.
Like what? Any examples stand out?
Yeah, there was one ML model that could predict a person's pure tone average. That's a key measure of hearing thresholds,
Right.
just based on other patient data, with a really low average error, like around 5 decibels.
That's quite precise.
And another used deep learning on images of the eardrum, otoscopic images, to estimate conductive hearing loss with about 81% accuracy.
So potentially helping with faster or earlier diagnosis?
Potentially, yes. Or monitoring changes. There are also models predicting outcomes for sudden hearing loss using various AI techniques.
And not just diagnosis, though. What about prevention or management?
Good point. One study developed an ML model for classifying noise levels in real time for minors, aiming to prevent occupational hearing loss.
Like a smart noise monitor.
Kind of. And another predicted how well someone might understand speech after getting a cochlear implant, with pretty high accuracy, like 87%.
Before they even get the implant. That could help manage expectations or tailor rehab.
Exactly. There was even one predicting implant outcomes based on how the brain adapts, looking at cross-modal plasticity, how senses like touch and vision might compensate.
That's getting really sophisticated. So AI isn't just analyzing data, it's getting built into the devices too.
Yes, that's the other major trend. AI-driven augmented sensors. Hearing aids and cochlear implants are becoming much smarter.
Augmented sensors.
Yeah,
Meaning they do more than just amplify sound.
right. AI is being used inside them to dramatically improve things like speech recognition, especially in noise, reduce background sounds, help with sound localization, figuring out where sounds come from.
And the fitting process you mentioned.
AI is getting involved there too. Some systems use machine learning, like Bayesian optimization, for real-time personalized adjustments based on user feedback.
So the hearing aid learns what you prefer.
Essentially, yes. One example mentioned was Whitex's system, where over 70% of users reported improvements and 80% would recommend it. That suggests it's working well for many people.
And deep learning is used for noise reduction specifically.
Yes, there are deep learning algorithms designed just for that, to separate speech from noise more effectively. And AI-based fitting systems, like one called FOX AI, have been shown to be comparable, sometimes even better, than expert manual fitting and could reduce the number of clinic visits.
That's a big practical benefit.
And it goes further. Hearing aids are starting to become multifunctional health monitors.
How so?
Some models, like Starkey Livio, have sensors built in to detect falls or track steps.
Wow, using the motion sensors in the ear.
Exactly. There's even a system called EarGait that uses sensors in the ear for continuous monitoring of walking patterns, gait parameters.
So your hearing aid is also tracking your mobility and fall risk.
Potentially, yeah. And cochlear implants are also becoming augmented sensors. They can capture electrophysiological data from inside the cochlea.
Like electrical signals from the hearing nerve.
Precisely. AI models can then analyze this data to monitor the health of the cochlear nerve or predict how well the implant is likely to perform long term. There are datasets being built specifically for AI to interpret these neural responses.
It's incredible. These devices are becoming so much more than just hearing aids. They're like windows into auditory health and even overall well-being.
It really highlights how good AI is getting at processing complex biological signals.
Which brings us back to that fundamental question. Okay, AI can process brain signals, auditory signals, but does it understand them in the way a human does? This feels like the perfect point to talk about artificial general intelligence, AGI.
Right. AGI is that sort of hypothetical AI with human-level smarts across the board, able to learn, reason, solve problems in pretty much any domain a human can.
And there's a lot of debate right now, isn't there? Like, are things like GPT-4 maybe early stumbling steps towards AGI?
That's definitely part of the conversation. And alongside that, you have some pretty strong opinions about whether AGI could be, an existential risk.
While others think that's maybe overblown or at least very far off.
Exactly. It's a contentious topic. Another angle sometimes discussed regarding AGI is whole brain emulation.
Simulating a brain on a computer.
Yeah, the idea of scanning a biological brain in incredibly fine detail, every neuron, every connection, and then running that model computationally. Ray Kurzweil, for instance, has made predictions about when that might be possible.
But that seems mind-bogglingly complex. Our brains are just so intricate.
They are, and critics point out that our current artificial neuron models are way simpler than real biological neurons. Plus, we might be ignoring other important brain cells, like glial cells.
And doesn't it ignore the body? The idea that intelligence needs interaction with the world.
That's the embodied cognition argument, yeah. That maybe intelligence isn't just about the brain's wiring diagram, but emerges from the interaction between brain, body, and environment. A simulation might miss that.
So this leads into philosophy, doesn't it? The difference between AI that acts smart and AI that is smart, or even conscious.
Precisely. You have the weak AI hypothesis, which most AI research operates under basically, that it's possible to create machines that exhibit intelligent behavior. That's achievable.
Okay.
Then you have the strong AI hypothesis, which asks the deeper question, can those machines actually have minds? Can they possess genuine understanding, consciousness, subjective experience?
And that's where things get really murky and debated.
Very much so. While we pursue weak AI goals building useful tools, strong AI remains a huge philosophical puzzle.
If we did get something closer to AGI, though, the potential upsides seem enormous.
Oh, absolutely. Imagine massive leaps in productivity, accelerating scientific discovery, solving complex problems like climate change or disease.
Faster medical diagnostics, personalized treatments, drug discovery, even better elder care.
New materials, automated scientific research, revolutionizing education, the list goes on.
But then there are the risks people talk about.
Right. Concerns range from misuse like autonomous weapons or mass surveillance to unintended consequences if superintelligent AI goals don't align with ours. And even, in the most extreme scenarios, existential threats.
And ethical questions about the AI itself, if it became sentient.
Exactly. What rights or considerations would a sentient machine deserve?
Yeah.
Again, lots of differing expert opinions on how plausible or imminent these risks are.
This idea of AI sentience is fascinating in itself. How was it defined in the research?
Antonio Damasio's definition was mentioned. Sentience is a kind of minimalist consciousness, the capacity for feeling, for sensation. It overlaps with emotion and consciousness, but isn't necessarily tied to high intelligence. Think of basic feelings like pain, pleasure, fear.
And it's not black and white, is it? Not just sentient or not sentient.
Right, it's likely more of a spectrum. And people even argue for sentience in things we don't traditionally consider, like plants, based on complex responses. The common thread seems to be some kind of complex physical substance, giving rise to feeling.
So could a machine, a non-biological system, achieve that? That's the billion-dollar question.
It is. And it ties directly into, does machine understanding require consciousness?
The sources made a distinction, right, between different kinds of understanding.
Yes, they propose 3 types. First, natural understanding, that's us, humans. It involves consciousness, subjective experience, that aha moment.
Okay.
Second, artificial understanding. That's what current AI does. It's algorithmic pattern matching, classification, prediction based on data, but likely without conscious awareness.
Got it.
And third, the hypothetical machine understanding, which would be like natural conscious understanding, but arising in a machine, a non-biological substrate.
And the argument is that our human natural understanding is inseparable from consciousness.
That seems to be the perspective presented. They used examples like solving those remote associates tests, you feel the tension, then the sudden insight, the aha, the pleasure. That feeling is part of the understanding process.
Or understanding abstract art, it's not just recognizing shapes, it's a perceptual shift, making new connections, another kind of aha moment.
Exactly. It highlights a potential difference between an AI merely detecting or recognizing something based on its training data versus genuinely understanding it, which seems to involve a deeper transformation of one's cognitive state.
And maybe holding multiple, even conflicting ideas at once.
Yes, that was mentioned too. Understanding often requires grappling with ambiguity and complexity in a way that current pattern matching AI might not.
Even though machines are crushing benchmarks like Super GLUE.
Right, but there's the worry they might be getting the right answers for the wrong reasons, statistical correlation rather than deep comprehension.
So how might we get closer to actual machine understanding or even consciousness?
Some researchers are looking towards brain-inspired AI architectures, particularly models based on theories of consciousness, like the global neuronal workspace theory.
The idea being if you build an AI more like a brain, maybe consciousness or deeper understanding could emerge.
That's the hope driving some of that research. It's a long shot, perhaps, but seen as a potential pathway.
Okay, so wrapping this all up, it feels like we've covered a lot of ground, from AI reading minds almost literally.
To AI transforming how we diagnose and treat hearing loss, becoming these integrated health sensors.
All the way to these really deep questions about AGI, understanding, and consciousness itself.
Yeah, the common thread is AI's rapidly growing ability to process complex information in ways that mimic and sometimes exceed human capabilities in specific tasks.
But that crucial question remains. Is it just sophisticated mimicry, or can it lead to genuine conscious understanding?
And that's the frontier, really, exploring whether consciousness is essential for the kind of flexible, deep understanding humans possess.
We definitely had a few aha moments ourselves, connecting these different pieces. You see how progress in one area, like processing brain signals, informs possibilities elsewhere.
Absolutely. It underscores how fast things are moving and the profound implications for healthcare, for technology, and for how we think about intelligence.
Which leaves us with a final thought for you, the listener. Given how quickly AI is getting better at interpreting all kinds of information, brainwaves, sounds, language, what do you think are the biggest implications for how we understand our own minds and what understanding even is?
Yeah, it really pushes us to consider the philosophical and ethical side of all this. What does it mean to understand, to be intelligent, maybe even to be conscious in a world increasingly shared with sophisticated artificial systems? Lots to think about there.